it's got some various items which we're not interested in. And one of them says QGIS desktop, again with the version number 3.40.7. You double click on that, then it comes up with this splash screen. And it does something behind the scenes. I don't know what it's doing, but it takes a few seconds. Right, and you get something a bit like this. Say mine will look different because I've got some existing projects. Now to install the plugin, which you should have done, there's a plugins menu. And if you click on the top item there, manage and install plugins, then it will connect to a server somewhere for all the possible plugins of QGIS. And it's got a search thing. And if I put in QSWAT, for some reason, then I've got lots of old versions around, but you should see one that says QSWAT Plus. And then you just tick the box beside it. If you don't see that, then it's installed, not installed, or installed in the wrong place. So once you've done that, you can simply say close. Well, if you click on it, it'll give you some information about it, which doesn't say anything very useful. Once we've done that, we can close it. And then there's this sort of little double arrow symbol up on the top right. And underneath that, again, I've got various plugins installed, so yours won't look quite the same, but there should be a blue box with S Plus in it. And if you hover in it, then the label comes up QSWAT Plus. You click that once, and that's when you get the start menu. Does that answer your question? Right, sorry, I should have gone through that originally. Right, so we're going to start a new project. So you can put a project anywhere you like, but it invites you, just brings up the standard Windows screen for maneuvering around your file system. And it's quite, I mean, most people probably have a standard place they're going to put their projects in. So I've got a folder called QSWAT Plus projects. You can call such folders anything. And because it's the example's called Robit, and I've got various versions of it, I've got a folder called Robit. Now, when you start a project, it doesn't invite you to immediately choose the project folder because you don't have one. It invites you to identify a folder where you're going to put your project. So my folder is called Robit. It can be called anything you like. And then it says, right, what do you want to call your project? So I'm going to type in demo. You can call a project anything you like. It's a good idea not to put a space in the name. I hate spaces in names. They make programming very hard. You can't start it with a number, but you can call it demo 27 if you like. You can call it demo 0.27, I think. Certainly you can use letters and numbers as long as you start with a letter.
Where should I put it with the folder?
You can put it anywhere you like.
Okay.
Right, where you put your project is entirely up to you. You can put it in your documents folder, anywhere, as long as you've got access to it, obviously. Try and put it directly on the C drive and it's not your computer, so you may have problems. Right, so I've called my project demo and I click OK. And you see the main QSWAT Plus screen changes. It's got a step 1 and a step 2 and a step 3, which is what we're going to go through some of at least today. It's got an about form. If you click on that, I see it's wrong, but don't worry about it. It tells you what the QSWAT Plus version is, and it tells you that you need at least 3.16.4 version of QGIS. But you know that, and we've got a much later one than that anyway. And it says it's using Python version 3.9, and that's wrong, but it doesn't matter. So you can use this to get at the SWAT homepage, but it's not very interesting otherwise. So in order to set up a SWAT model, we need essentially to do 3 things. That's why partly it's called step 1, step 2, and step 3. We try to keep the interface simple, right? You don't start with step 3, you start with step 1. And so you need to do 3 things. One is to set up the topology, to decide where the water will flow. The water that falls on the land, where does it flow? Which stream or channel does it go into? Okay. What are the other points that flow into that channel? Those are the essential things you need to know. So that's the process of deciding that. It's called watershed delineation. Once you've done that, then you can add, as Aaron was explaining, you need soil data, you need land use data. And once you've added those, then you can calculate where the HRUs are. So that's the HRU creation, which is step 2. And the third step is we use the SWAT Plus editor, which is a tool that initially allows you to add the climate data. Once you've done that, then you can make lots of fine adjustments to your model. But what I'm going to do is, once I've got the climate data, I go immediately to use all the built-in assumptions about the other parameters and create a model. And all of you are going to have a running model I hope well before the end of this workshop. If you don't get it today, it'll be your homework, right? But I guarantee that all of you will have a running model by the end of today, even if it's your homework, but we'll get there. Okay, so the first thing we want to do is delineate the watershed. So we click on step 1, and then another form opens up. So this form, first of all, says, where's your DEM, your digital elevation model? You know what a digital elevation model is? Yes? It's a raster. That's a map which is essentially a grid. Not square, but rectangular, usually. And at each point in this raster, you have a number, right? And the number should be the elevation, the height of that particular spot in meters. You can actually have them in feet as well. So I've only ever seen one example. I've been doing this 20 years now. So almost certainly in Korea, that use will have the elevation in meters. And you have the elevation at every point. So that's the DEM. DEMs come with, like all maps, they come with possible projections. And essentially there are 2 kinds of projections. There's one called latitude longitude, which is close to the actual land as described on a spherical surface, and the points in it are identified in degrees, fractions of a degree. There are also what are called various projections, and we need a projected DEM. And in particular, we need one that is what's called an equal area projection. Does anyone know why we need equal area projections? Well, we think about what's the most important thing is water, right? How do we measure precipitation? It's a depth. Yes, we get 10 millimeters of rainfall today. Okay, but SWOT needs volumes of water. So how do we turn our depth into a volume? We multiply by the area. Okay, if we've got an equal area projection, then I know that every pixel in my digital elevation map represents the same area, right? So if I know what the depth was on that, I can just multiply by the area and I multiply by the same number everywhere. If I had to calculate that number for every point in your watershed, it would be very slow. So instead of making it very, very slow to run, we say you must convert your DEM if necessary into an equal area projection, and then things will run smoothly. Having said that, a very common projection to use is UTM, Universal Transverse Mercator, and actually it's not equal area, but it is so close that in any watershed you're likely to ever try to model, the difference is fractional, can be ignored. Right, so if you don't know what projection to use UTM, but there are other ones that are possible. Okay, and this has been done already. Right, the example data you've got already has the DEM. Right, so once you've installed QSWOT Plus, if you go to your home directory and /users/your username, so let's do it in the long way so I can show you. All right, under users, under the C drive, users, there's a folder with your name in it, like Chris, which is mine. And inside that, because that's where SWOT put it, almost certainly, there's a folder called SWOT Plus. And inside that, there is a folder called Example Datasets. And inside that, there's a folder called Robit. Okay, now once you've found that, click on the right button and say Pin to Quick Access, because we're going to keep going back to this folder. And if you have to do what I just did, it'll take you all day. Huh?
It's too small, it's not visible. Can you try the text size?
So I should increase the screens folder.
Yeah.
If I can find it. Is that any better? Not much. Right, you've got to find the Robit folder, which is inside users, your username, SWOT Plus, example data sets, Robit. Once you've found Robit, then right click and put it into your quick access. It should be here. Did it change something?
I don't know.
You probably need to open the window again to
Yeah.
get it to have any effect.
Okay. So it may be. So I will have.
Okay. So I've already got my Robit in my quick access. Oh, it's not come up any larger. I'm sorry. Inside Robit, you find a number of folders like Climate Robit, DEM, Land Use, Main Outlet, Observed, Robit Streams and Soil. You click on the DEM. Then it's got a couple of, yep. So there's a folder called SRTM_30M, which was someone's way of remembering that this was a 30 meter. So the pixels are squares 30 meters in size. And if you click on that, then you see you've got a whole collection of files. This is a particular format of a raster, which was always called an ESRI raster. And the convention in QGIS is if you double click on the header file, which is hdr.adf, the first one. Oh, that is larger now, isn't it? And so you click on that, and the QSWAT Plus immediately does several things. It uses we're going to use internally some software called Talbin, which is some software for doing calculations starting with DEMs. And Talbin needs a particular format called a GeoTIFF. And because of that, the tool doesn't require that you start with the GeoTIFF. It says you can start with any form of DEM you like, as long as it's projected. And it will convert on the fly, behind the scenes, into a .tif, and it will store it in your project. So you can see that the path you've got is one. That's right. I've got a QSWAT Plus projects folder. Inside that, I've got a folder called Robit, and then the demo, which is the project folder. And then a subfolder of that called Watershed, another folder of that called Rasters, another subfolder of that called DEM. And inside that is created SRTM_30.tif. Now, this is part of the policy of QSWAT Plus, that all your maps, no matter where they came from originally, will get stored or copied into the project. This is done intentionally, because it means if you want to share it with the colleague, or you change your machine, or you work with your laptop at home on a lab machine at work, you just copy the project, and you can. There's nothing else to copy except the project folder. So everything that is created by QSWAT Plus will be put somewhere in the project folder, and there's a sort of hierarchy of folders so that you can find things easily. Right? There's always the subfolder called Watershed. Inside that you have rasters and shape files. Inside the rasters you've got the DEM folder and a land use folder and a soil folder, so you can find very quickly the things you want to look at. Okay, so that's been done on the fly, and the tool also creates a hillshade file. And I'll show you why it does that, because if I remove it, get a very different image of your watershed. With this one, you've got much more idea of what it looks like. This flat green area on the left is actually a lake, and our watershed is going to drain into that lake. Okay, but you can see where the hills are from the hillshade. If you don't like it, you can obviously just remove it. Now I've got this thing in a state where I can't actually find anything. Rat. Why has it done that? Go away. Right, sorry, I've lost my map, but I don't need it anyway. So we've loaded the DEM. Now, the idea is that the Tailwind software is going to calculate, say, where the streams are. It calculates where the streams are by saying, where will the water flow? So from each point on the map, it calculates where the water will flow. So obviously, as it flows downwards, it accumulates. So at some points in the map, will have a property that 100 pixels drain into them, 1,000 pixels drain into them. And you define a watershed by saying, you define a stream by saying, once it gets to 1,000, the stream will appear. So downstream from that, obviously more points are flowing into it, and all the points down there will, from then on, will have a larger accumulation. So it says once we reach a certain number of pixels that flow to this point, then a stream starts to be formed. And we're going to decide what those numbers are. And in Q-Swap Plus, we have two levels of stream or river, right? Well, the bigger one's called stream, and then the smaller one is called channel. So typically what you do is you start with a number for the streams, which is 10 times bigger than the number for the channel. Now, Q-Swap Plus will give you an estimate. It's very crude, right? It has nothing to do with what the topology looks like. It will give you the segments regardless of whether your area was flat or mountainous. But it seems to give a reasonable approximation to what you want, right? So it's always worth trying with the numbers that are produced by the tool, but you can change them, as I'll see in a moment. But another thing you can do, and it's particularly useful if your area is very flat, is use knowledge about where the streams actually are. So if you've got a map that shows where your streams are, and you can project it into the same projection as your DEM, then you can use it and say, I want the stream to be here. And the way it does that, it lowers the elevation by a standard amount. The default is 50 meters, which always seems to be like a ridiculously high number, but it seems to work. You can change it if you want to. So that's called burning in. And I have a stream map for this example, which I'm going to burn in. So if you tick to say, I want to use burn in, right, you just click on the checkbox, burn in existing stream network, and then the standard 3 dots button, which means I want to find a file. And remember, we can go to where Robit is. And in Robit, you'll find there's Robit streams. And inside Robit streams, there's one called robreach.shape. Now, some of you may find that this file is called robreach, and the robreach.shape.xml is called robreach.shape. Now, if you've got that, it's because you haven't done something which I think is a good idea, which I'm going to do if I can find. Okay, Sorry, I can't get hold of things on this screen because the things are much too big. So I'm going to collapse things for a moment. I'll come back to this. It's a good idea not to have anything full screen because you can't find anything. Why can't I find anything? Eventually, right, if I just open some random folder, if you open up Windows Explorer under View, you can see there's a thing called File Name Extensions. And I advise everyone to turn that on. Right, it's just just open Windows Explorer, select View and File Name Extensions, and tick to have them on. And the reason being, if I can go back to oh, have I lost everything? When I was looking at Robert and Robert streams, right. See, if this dot shape is not there, but the dot shape on the next one is there because it drops the XML, then you can click on the wrong one and wonder why QGIS say, I don't know what this is, I can't load it. Right, you need the dot shape. Of course, it does say on the right-hand side it's a shape file, but you tend not to notice that. You only look at for the file extension. So robbreach.shape is what I'm going to use to burn in. So, as I said, you can decide what area you need to create a channel, which is remember the smaller size, and what number I need to create a stream, and we'll see what that effect is. And you can decide what unit to use, so I can change it to hectares. I'm going to change that to 9. Only to show you I can really, but you can change yours to 9 as well, and to 90. And you notice that the channel thresholds and stream thresholds, when measured in number of pixels or number of cells, now comes up with 10 or 100 because it's a 30-meter pixel size. So 30 by 30 means you've got 900 square meters per pixel. So that 100 pixels will be 9 hectares. And you can change this by changing the cell size or the threshold in this box, or by changing this box, and you can change the units, whether it's hectares or what other square meters. You can even have square miles or acres. If you know what an acre is, you probably don't. Okay, then you click Create Streams. And the tools will trundle away in the background. My biggest thing is so big I can't see what's at the bottom, but you get some messages at the bottom about what process is being used. Yes? Ah, right, okay. So someone's got a message saying they can't find MPI, so it's not going to use it. Right, I didn't tell you to install MPI, so you're not surprised we've got this. MPI is some software which you can get from Microsoft. It's free, multi-processor interface, and it allows for some tasks to be divided into pieces and run in parallel. Okay, but when you're processing a large DEM, it's worth using it. Okay, but you don't have to use it. And there's a box at the bottom left. I've got Alan Turing's birthday coming up. There's a box at the bottom left of this form that says number of processes. Yeah? And if you set it to 0, then it won't use MPI. If you've got a machine that has 8 CPUs, partition your CPU, then you can set it to 8, and it will use all of them. Right? You can even set it to use 16, and still only use what's there, but it will try to run not things in parallel. Okay? And what happened was that the default is probably 8 or something. And if you don't have MPI, then it just warns you, I can't use MPI, so I'm going to ignore what you said. I'm not going to use 8 processes, I'm only going to use 1. So that's fine. But thank you for that. Reminded me to tell you. Okay? So everyone got the streams? Actually, got channels and streams. If you change the view, remove the streams, you'll see the channels are darker blue. So the stream finishes here and the channel, because it needs a smaller threshold to start. So at this point, we've got enough pixels flowing into here to create a stream. And at this point, we've got enough to make a channel. How did I get?
I only got the red.
The red is actually the burning file. So I can take that, if I remove the visibility of that. I can do it on here. I'll do it on there. Right, it's probably a good idea to remove the visibility of the burn-in. But I got this by clicking on Create Streams. Did you do that? I'm sorry? Got a problem with it. Sorry, I've just... Oh, just a bit cancel. Yeah, sorry. If you get Windows coming up saying I need permission to run MPI, the problem is that MPI is capable of running processes on sort of cluster of machines. Therefore, it can ask for permission to connect to other machines. And you don't need to give it that permission because we're only going to use it within the machine you're using. Where you just click cancel in place. Okay? Yeah? Yes? Right, that's the town dam output. I'll talk about that in a moment. Right, one of the tabs is called tower dam output. You don't normally want to look at this, and if you do, you apparently get a whole lot of errors. Right, these errors just crept in recently, and they're actually harmless. Starts looking for a lot of stuff that isn't there, but it actually doesn't need it. Very annoying. In my very latest version, I've got rid of these error messages. But basically, unless things actually go wrong, completely wrong, you don't need to look at the tower dam output.
Some users are getting totally but it's not asking them a lower node. And then it's going to be extreme. It take
What's the error?
that TODM related. TODM, TM, yes, that one related. I'll show you. Okay. So we have one chair there, one chair there, and one table over there. Somebody wants to come in for it. Yes, it depends on where you can say, especially, you have what, this big what the hill. Even when it will convert, even when it will. When you, how much complexity? And then according to that, you create more detailed statement or less detailed. Usually it depends on your interest. Maybe some places, since most of the time, and we can be still then we'll give it to work as well. But you want to be something else, each small location to work on, and you can so they didn't have there are some units that we have very. I should not be able to go for it as we identify what's on the I put things to say my rules what I do understand and one stop listening. Depending on the was going to be started or it is funny, there's almost a deal to figure out the best of the thing. That goes to study. See when you might get into and there's always some things of just man. That's okay. Sometimes, but I don't want to say that I like get those good job. Right. Want to go more understand one side is society, so everything would be compensation. So you can but I would really not share this. Lots of people depends on what it is, that's what all so I think you find will they have 3-4% is in the same area? Hope they can be same area. Yes. I'm gonna have to. It's always going to you pick it up at that time? I'll try and figure it out. Okay. Get one of the machines. Okay. So that error that you are facing, and there was someone facing. So that error is new for us. So we need a little bit digging why that is happening. So Chris will try to take one during lunchtime and try to resolve that error. So for now we will move on. You watch it how we are going, and during the lunchtime you will try to resolve this error. Okay. Yes. Sorry. Yes.
Question. How did you decide the number of cells and what area?
The tool will calculate a number when it starts. Okay. So you can try with that.
Yeah.
And if you think you need more streams, you change the numbers. You need more channels, right?
The bigger number makes me fewer streams.
Yeah.
No, the opposite. The number is a requirement about the number of cells to drain to this point, for this point to become part of the stream. So the bigger the number, the higher the requirement, and the further downstream your channels or streams will start. Okay?
So there is no border rule. It depends on your objective as well as like how much computational expensive your model. So you can get everything from 10 to 100 for 10 at the same point. So it depends on you. So you can try with the number before and then decide whether you want more complexity or less.
So if you have a like small plot, then it's a small number.
Yeah.
But we want a real situation, a real world situation. We want deep where it is, the children where it should be. So how can we do this?
So the binding option is for that one. That you can. So Chris, you want to show that?
Well, the burning option will help you. Won't necessarily help very much with where it starts. But where a channel starts is not usually, well, it depends, example, whether it's December or June. Right?
But there are options available where they can utilize their own shape files.
Yes,
Yes.
there is another option which I have not talked about yet.
Yeah. So
But-
please learn about it.
The second option in the delineation form is called use existing watershed. Okay? And if you can supply your own shapefile for the subbasins, we'll see that in a moment, and your shapefile for the channels and a shapefile for the streams, then you can use that. And then you get them exactly where you want them. Okay? Or sometimes you may need this because you're told that your watershed must be the same as your municipal boundary or something. Right? But that's what you do if you can't, if the delineation won't give you what you want, but you have the information. And you can read the manual, it will tell you what attributes and so on the files need to, so they match together. Right, I'm sorry some people have got a problem with delineation. We'll see if I can sort it out at lunchtime. Right. So now the next bit I'm going to do, but I don't want you to do it. And I'm just going to show you. You can see we've got streams coming from the north, one or two coming from the south. So there are streams draining to the north, draining to the south, and into the lake. We want a particular watershed. Okay, if you just carry on without saying where the main outlet is, it will take everywhere the stream crosses your DEM boundary as an outlet. Okay, if you're modeling an island, you're doing Jeju as a whole, of course you have lots of outlets, probably. Right, so you just use the DEM and say, all right, I'm not going to mark any, I'll just let it work out where they are. But typically you only have one. You might have two or three, but so what we want to do is decide where the outlet is. So I'm going to show you how to do it, but we haven't had very much time, so I don't want you to do it. If you say draw inlets, outlets, so you click on that, then it brings up a little form saying, are you marking an outlet? Or you can also use this to mark a reservoir or a pond or an inlet or a point source. A point source, you probably guess, is where you've got something flowing into your, say, a factory that's got an outlet or a water treatment plant or something. You very rarely use the point source with QSWAP Plus because QSWAP Plus puts a point source on every channel, as we'll see later. The idea being you may have half a dozen, but instead of making you mark all those yourself, it marked one everywhere, and then if you've got an actual point source, you can provide the data for it. Okay, so you probably don't want to mark them because you're going to get plenty to choose from anyway. But you do typically want to mark where the outlet is. So what you do is you open this form, and then you click on the map where you want the outlet to be. And then that's all you need. You say, okay. Now, if I look at this, at what I just did, you will see, wow, I got it very close. Well, these squares you can see by zooming in are actual pixels. So I got this actually much closer than 30 meters. But typically, of course, if you click on the map, you don't get it exactly on the stream. So what the tool will do is then snap it, right, which is moving it to the nearest channel or stream. It's probably actually stream for an outlet. So it will actually mark it exactly on the channel, but it does a snap. And if it fails, it will tell you. And you can set how near it needs to be by putting a limit on the snap or the snap threshold. So if I go back to my form, I can see that. Right, so the snap threshold is actually 300, which is, again, it's an arbitrary number, but you can change it. It's very rarely you need to. I think I've only ever found one example where I needed to, but I had to make it 600. But or you could just move the point because it's only a shapefile. You've got the ability in QGIS to move any point, for example, to edit shapefiles. Right, so, and if you chose that option, notice it will create a file called drawoutlets.shape. And again, it's in your project. It's in the watershed shapes folder. But we've got a shapefile with an outlet. In this case, I want you to click on the choose file button, or make sure that use an inlets outlets file is ticked. I think that's the default. So you click on that, go to Robit, and inside main outlet, there's a file called mainoutlet.shape. So you select that and click open. And it's marked it. I'm going to hide the one I created. Right, in fact, that's not terribly close, but it's close enough, well within 300. And then we can click on create watershed. There's a couple of other options, well, one option really. You can use what are called grid models, which divide your watershed into rectangles. And sometimes they're useful, but I'm not going to talk about them in this tutorial. All right, so you make grid should not be ticked. If you do tick it, then you have to say how big it is. So it doesn't matter what, and then you leave the default of 1. But don't click on make grid. Just click on create watershed. All right, and apart from the people who've got problems with Towdem, right, there is a very useful button. I will show you if I can get it to work. Called zoom to layer. There are several sort of ones that look like magnifying glasses. But zoom to layer, if you choose the, once you've got it, the sub-basins layer, and then click on that, then it makes it the right size. Whoops. So we can see that now we have, as well as the streams and the channels, we've got an outline in red. Okay, the outside of that is the whole watershed. The portions of it are the sub-basins. So you have sub-basin. Sub-basin here. Right. The sub-basins are the areas that drain to a reach of the streams. A reach is a piece from the end to the first junction or between junctions, okay, or from a junction to the outlet. So that's a reach because there's a junction here, okay, and the area around it is called a sub-basin, and it's the area that drains to that into that particular reach. Right? So sub-basins go with streams. Later, the same notion will apply to a channel, and those are the the basis of the landscape units. They're not exactly the same as landscape units, as you'll see. So apart from people problems with NPI, everyone else got the sub-basins? Yeah, great. Jacqueline, could you look up the address for it or where to get NPI from? Because what I'm going to suggest is that people download it and we'll try using it. That may be the easiest way to solve the problem. So if you can find out where it is for me so I can tell everyone. Thank you. Right. My mouse keeps escaping. Where is it? Oh, there it is. Oh, I've got to crash this again. Right. Okay, so we've done create watershed, and we see there are three options underneath that with some tabs. One is add lakes, and I'm not going to include a lake. I mean, I've got one on the edge, but add lakes means lakes inside your watershed. Okay, you can look at the manual, which describes in some detail about how to add lakes, but this example does not have one. Another option is to merge sub-basins, and this is sometimes useful, but not actually was more useful in SWOT than it is in QSWOT. So what you can do is you can choose a sub-basin. I've managed to hide mine, and say I would like to merge it. Or more commonly, and again, I'm going to do this, but I don't want you to because it's slightly complicated and it's not necessary, but I'll just show you how it works. And again, I've lost the... Right, so don't do this. Okay, so if I say merge sub-basins, usually the reason is to get rid of a small one because it's not much use. You merge it with this one downstream. Okay, now if you've got 100 sub-basins and you want to get rid of 5 of them because they're too small, right? You could do it one at a time, but actually there's a small method which I'm going to show you. We say I want to select the small ones. You say, what do you mean by small? Well, if it's only 5% of the typical area of a sub-basin, I'll merge it. So you can say, I want to select those. And if I can show you what it would do, in this case, the only small one is there, right? Now you actually can't merge that one because it's got the outlet in it, right? There's two reasons you can't merge it. One is you merge downstream and there's nothing downstream. The second is you try to merge it, you'd lose where the outlet was. So there are rules. And in fact, this breaks two of them. One, it breaks the idea that there has to be something downstream. And the second rule it breaks is that there is, if there's an inlet or an outlet for this subbasin, you can't merge it. So when you do try to merge it, the tool, being kind, says, no, sorry, you can't do that. Where would it be? Yeah, that's right. When you've got your selection and happy, because you can also mark them. Right, so I can select this subbase and say I want to merge it. Whoops, I didn't mean to do that. If you click outside, it goes away again. And then if I try to do the merge, I can get the form back. It will say you can't do that. Oh, it's all right. I'd lost the other selection as well. But if I had selected that one, it would say you can't do that. Okay. Right, now what I do want to do instead is something called Create Landscapes. And you click on the Create Landscape tab and click on Create, bring up another form. I hope. Oh, there it is. Okay. So you can distinguish between areas close to the stream, called the floodplain, and areas that are higher up, called the upslope. It's not, you don't need to do this, but it's an option you have. Okay? And we're going to do it for this example. And there are three techniques for creating, essentially you create the floodplain and the rest is upslope. All right, so you're going to create a floodplain there. So there's a crude way of doing it, which says, I'll just put a buffer around the stream. Actually, around the channel. Yeah, it's channel. So if you select, so we want you to do this, select the buffer option. Whoops. And it says, how wide do you want it? Okay, and the default is to say it's 10 times the width of the stream. So what's the width of the stream? Well, internally there is a calculation of how wide the stream is likely to be based on the area draining to it. So they get larger as you go downstream. This is based on statistics that were collected some years ago in the United States, and whether they are appropriate for Korea or wherever you're modeling, I've no idea, but you can change the numbers. It's in the parameters. So you can click Create, and very quickly, because it's pretty simple, it creates another file called floodplain by buffer. Okay, and if you decided that wasn't big enough, you can change the number to say 20 and do it again. And it will create a new one with a slightly different name because it'll have 20 in it rather than 10. Okay, I'm not sure if anyone ever actually uses that because it's a bit too primitive. Right, the most common option, which is why it's the one that started, is to use a method called DEM inversion. DEM inversion, well, the problem is I want the floodplain, the best definition we found for it, someone did several experiments on this, is to take the proportion of the height of a point above the channel compared with the height of the ridge above the channel. And the typical fraction, this is 10%. Okay, but it's not just any point on the ridge, it's a point on the ridge that drains to the point we're interested in. And it has to calculate this for every point. Right, so it takes a little while. But the main problem is finding where the ridge is and where's the appropriate point on the ridge to use. So what's a ridge? So one way of defining the ridge is to pull your DEM inside out. So imagine it like a face mask. Okay? Pull it back in, pull it the other way, so you'll notice a low point instead of a high point. Right? So similarly, the ridges become the low point in the inverted DEM. And then you use the standard techniques for deciding where the streams are in your inverted DEM. And those are the ridges in the original DEM. Right? So it's quite called inversion. So let's calculate it. So again, you can put in some parameters, but the ones that typically use the same parameter for the size as you used for the channel creation. Sorry, that's the stream creation, isn't it? Yeah. Anyway, that's the default, and it's usually about right. And the slope position is this 10%, as I said. You can change that. Right? So what you do is you click create, and it takes a few moments. As I say, it has to quite a lot of calculation to do. And then it's going to produce another floodplain map. So I'm going to hide the by buffer one. And you can see it's got its estimate of where the floodplain is. That's not necessarily that means that the area will flood. It's just the points that are less than 10% above the stream compared to where what the height of their ridge point is above the stream. And if you don't like that one, you can try changing the parameters, and you create another one. I have seen this go wrong when you have a watershed that has got low-lying, some steep canyons, and higher up it's fairly flat, sort of plateau. Then this goes wrong. You get sort of big areas that have got sort of horizontal streaks across them, right? And in such a case, you can try the third method, which is the one called branch length. Branch length has a different definition of what a ridge point is. In America, you talk about the Great Divide. Yeah, I've heard that. You know what the Great Divide is? Well, there is a line in America such that if a drop falls and happens to split there into two, one of them will drain into the Pacific, and the other one will drain probably into what Mr. Trump would call the Gulf of America. Everyone else would call the Gulf of Mexico or the Caribbean. Right? So it's called the Great Divide. Right? And this is the definition of branch length. If you can find a point such that, or at least find 2 points, 2 pixels, such that if you calculate it from this one and from this one, where their channels would meet, or where these drops could meet, right? If it's long enough, they must be in separate subbasins. If it's fairly short, they're in the same subbasin. So if you made the length, somehow bigger than the subbasin size, then you know that such a point must be on a ridge. Right? But if so, it takes pairs of points, calculates how far away their sort of stream flow lines would join. If that's big enough, it says that's a ridge. Right? This is an even more complicated calculation than the other one. for calculating ridges, and it takes, I reckon, about 10 times as long. But you can do it. I think we've got time. So you click create and it will take a little while to run. And it will tell you roughly what it's doing. And it will create another map, another floodplain. Or if you've got a map that was created in your area for where the floodplain actually is, you can use it instead, right? Provided you give it the right name and put it in the right place, the tool will find it. Right. I can't see where this is running because I can't see the bottom part of that window. Oh, it's done it. Right. So you can see actually in this case, and it's commonly the case, that it's not much different from the one-bind version. Okay? But the point of creating this is that now I told you a landscape unit corresponds to a reach of a channel, but actually landscape units are now divided into two. So reach for most channels, we have a floodplain landscape unit and an upslope landscape unit. Okay? So that's what landscape units are. They're the areas that drain to the channel but will be divided into the upslope one and the floodplain. And your HRUs will belong to one or the other. Okay? And the rules for where their water goes will change a bit. Like Aaron was saying, normally HRUs just drain into streams or into channels. But upslope, the rules for upslope HRU drainage is not quite the same as the rule for floodplain HRUs. Okay. No other problems? Right. So once you've finished, and you can generate as many floodplains as you like, as we'll see, because I'm going to use one later, but you don't have to just generate one. You can generate them until you've got one you like, or that looks appropriate by changing the parameters. Okay. And now I have a problem because I can't actually. Ah, you can. Right. And finally, you press OK. But it says, essentially, it says delineation is done. If I can find the main form. Right, it says done. Right, you can press the button and do it again. Right, but basically, and now it means that the next step, which is create HRUs, is now available. Previously, it was grayed out. Right, because you cannot create HRUs unless you've got a delineated. And what it's done, that final step, okay, has also numbered the subbasins. And I hope I can show you that. You make sure that subbasin is selected and you just hold the mouse somewhere in a subbasin. It should tell you what its number is. And there are numbers, but they're a bit hard to find. Now, there's a number 4. And in fact, it will tell you subbasin 4. And of course, you will need to know this later, because if you want to say, I want to look at the outlet for the whole subbasin, for the whole watershed rather, then you want to choose the subbasin that the outlet is in. So what's that? Well, you can see 7, but if you just put the mouse there, it will. Oh, it's 5. That's no. Hang on. No, it says 6. No, I was just not being careful because it's small. Right, you can always zoom in a bit. So that's sub-basin 7. So the tool tries to help you work out what's what. How are we doing? Any questions? Right. Well, you've done half the work already. Well done. Okay, so you have a question? Oh, it's random. Random. Yes. No, I don't know of an algorithm that will give you something sensible because it's like a tree, right? I mean, essentially, sub-basin are a tree, right? And I don't know of any algorithm that says this is a sensible way to number them. Okay? So if you run this again, you change the parameters, like you change the stream threshold and run it again, you may get a different number of sub-basins, and the numbers may be quite different. Okay? I don't know what else to do. They are numbered consecutively. Right? There will be a sub-basin one, and if you've got 9 sub-basins, the biggest one will be, or the one with the highest number will be 9. But even that's not essential. The old SWOT model, you had to do that, so it ended up the same, but it's relevant. Good question. Right, we'll carry on then. Is lunch at 12, Jacqueline? Is lunch at 12? Right, okay. So did you find that address? Okay. So can I show people that? Probably, if I can discover how to open. Which web page? Oh, the sorry? No. Ah, right. If you have a problem with MPI, I'm not sure that this will necessarily solve the problem, but I will try, and that is to install it. So if you go to the workshop web page, there is an address, or there's a connection there to Microsoft MPI, which is what you want if you're running Windows. And if you can download it, that may help me solve your problem. I can't guarantee it, but it's worth trying. And the rest of you might like to do it anyway. Okay, so that's on the web page that has details of this workshop, the one that you were sent in an email a while ago. Okay, so if someone at least who has the problem with MPI can download that, I may be able to solve your problem. Thanks, Jacqueline. Right. So we go back to the main SWOT form and open create HRUs. So to create HRUs, we need what? Land use of soil. Okay, we know the elevations. And that means we've also been calculating, we actually do know the slope as well. But the critical things we need are land use and soil. So you need maps of those. They're rasters, just like the DEM was. They do not need to have the same pixel size. Right? Quite often, for example, soil maps can be quite coarse. So the pixel size in the soil map can be quite large. Land use, not necessarily so. There's not much point, but there's no point at all in having something that's more detailed than your DEM. Because all that will happen is that the way the land use is measured and the way the soil is measured is the center of each DEM pixel. It will say, what's the land use there? Right? So if your land use has got very, very fine, it will arbitrarily, so apparently to you, right? If you've got coin and alfalfa and rice right next to each other, which one gets picked appears to be random. Right? So there's no point having a land use map that's more detailed than you're taking. But of course, you could go back and say, well, actually, what I should do is divide by DEM, and I should sample it. Then, of course, it will appear sort of lots of flat bits, but at least if they've got different land uses, you can still model it. That's why it happens. So it will say at the centre of each DEM pixel, what's the land use and what's the soil? Okay. So all it needs to be able to calculate is what's in what pixel am I in at any point in the DEM. So it doesn't matter if the pixels are larger, as long as it's got the same reflection. It's the critical thing. And of course, QGIS will do the projection for you if you need it. Right, so we click on the Find a File button, one with 3 dots, and it says select a land use raster, and we go to the Robit directory, and we find the folder called land use, and it's got a folder called Rob land use new, and it's actually another Esri another Esri raster. So we pick hdr.adf. The name is always the same inside the final folder, and click on open. And again, it will copy that file into your project folder. So you're never going to lose it. It doesn't matter if you lose the original or if you just downloaded the original from somewhere. You now have your own copy. It doesn't need to be a GeoTIFF. It could be any of a huge range of possible raster formats. So it leaves it as it is, if possible. So you can see that what it's done is it's copied the Esri file, and it's called hdr.adf, but the name is exactly the same as the one that was copied. Similarly with soil, if we click on the click on the button for finding a file and go to Robit, and then find the folder called soil, and inside that there's what's it called, MOWR. Someone once told me what that was for. I don't know. And it's an Esri raster, so we pick on hdr.adf. We click on open, and we get a TIFF file. What happened was the soil map was a lot bigger. But if it's a lot bigger, it doesn't really matter, because QGIS is only going to read the soils within our watershed. It doesn't bother reading anything else, right? But if the soil map is sufficiently big, you say, oh, this is silly, and clips it. And the clipping mechanism I use just generates the TIFF. It doesn't actually matter. It doesn't matter that it's being clipped. People often clip their maps much too much. Right? When people have problems, I often see they've clipped their DEM to the outline of the watershed, which is silly because you're losing information at the edge. Right? When you want to calculate the slope at some point, you have to look at all the points around it. And if you've lost half of them because they're now outside the watershed, you're just losing information. So unless you need to clip your DEM, don't. I can't think of why you would need to. Well, occasionally you need to because it's a way of controlling where the boundary is. So if you've got a boundary which extends outside what you think it should be, because you're supposed to use a particular definition of what your watershed is, if that's imposed by the local authority or something, then you might need to clip the DEM to avoid the thing getting any bigger. But sometimes I did recently get a complaint from someone who said, I clipped my DEM to the watershed, and how I knew what the watershed was, I don't know. And the tool doesn't include it all. Right? The sub-basin at some point came in from his boundary. Right? And the problem was that the calculation suggested that that area would flow away, not into his watershed. And I don't know what he did about that. I suggested he try cutting in the stream, see if they can get the flow to go the other way. But he never answered, so I don't know what happened. But the tool will calculate what it does. So you have to live with it or define an existing watershed to get around the problem. So, land use and soil maps can be as big as you like because they're very, very big. The tool will clip them for you, and they can be any pixel size as long as they're in the same projection. If they're not in the same projection, you will get a complaint. Right. Now, a land use map or a soil map is just a grid of numbers. Right? For a DEM, we know what the number is. Okay, it's the elevation in usually meters. So what's number 3 in the soil map? What's number 5 in the soil map? What's number 7 in a land use map? So you need a way to interpret the maps. Okay? And the interpretation essentially comes in 2 steps. One is you have to have a table of properties of your soils, right? What's the property of the soil? The controlled infiltration, or the proportion of loam.
Connectivity, soil connectivity.
Not soils have lots and lots of properties. Let's just try to think some examples. So conductivity is one. Right? How many layers are there? What are the depths of the layers? Okay, so you have database tables with all this information about each soil. Okay, so you have to get away from a number from a map like soil number 7 to a line in the table of the database table of information about the soil's properties. So usually soils have a name, typically something totally unreadable, like C37-43-A or whatever. So what you have is a table, a separate table, very simple one that simply says soil number 7 has this name, soil number 8 has this name, soil number 9 has this name, so on. And then the tool can use the numbers it reads from the soil to use what's called a lookup table to get the soil name, and use the soil name to get at the line in the table of information, the properties of the soil. So for each soil, or for each soil map, you have a lookup table. And similarly for land uses, now for land uses, the second table is called the plant table, and is sort of standard to swap plus. But soils vary so much that almost certainly, well, you may have to typically find somebody else who's used the same soil map as you and say, can I have your table? I think. But for land uses, there's a standard table that's used by swap. You can replace it, but there is a standard table called plant, and that has the properties of each plant. And again, each plant has a unique name, and there's a lookup table. You have to create or find a lookup table that maps the values in your land use map to the names in the plant table. So, and where is all this information? Well, normally it's in the project. Each project has its own database. It's given the same name as the project, and it's stored in the project file. So in demo, we've got demo.sqlite, it's an SQLite database. But if you've put your soil or land use information in some other database, you could use that instead. Right, so that's why there's an option here, which is not very often used, to say, for my land use and soil data, I want to use this special database, and then you can select it. All right, and the standard way, you press this button and it brings up the form to find it. And then you say, this is what I want, and then it will get copied into your project. But what we need in the short term, well, I'm going to use standard things or import something. So I'm going to use the project database as it is. So I won't touch that line. Most of the time, you will never change this. Right, now for Robit, we have lookup tables. And this is the way we import them. You click on the land use lookup button, and you will get a list of all the tables in your project database that have land use in the name. Right? It avoids you getting 50 names there that you've got to sort through. Right? So there's a couple of example land uses that are already in the project database. Or you can say, I've got my own table and it's in a comma separated values file, a CSV file, right? Which means it's a simple file with two columns. Well, it's not, you can't see it as columns necessarily. Each line has got a number, comma, a name. Apart from the very first line, which you're supposed to get what the headings are, but actually the headings are never read. It assumes your first line is headings, right? Like land use and value or something, or land use and name. And following that, you've got numbers. On each line, it's got number, comma, a name. And the name, of course, is going to be in your land use, in your plant file, or there's a separate one called urban. So you can get things like urban low density, urban medium density for where you've got towns or cities. So that's another kind of land use. And and by convention, they all start with a U. But anyway, your lookup table is either a name in the plant database or it's an urban name. And in case of Robit, we click on Use CSV file. And then of course, you always think to yourself, am I looking up was it the land use table or the soil table next? But luckily, there's always a heading which tells you which one you're looking for, right? Choose land use lookup CSV file. Ah, yes, that's what I want. So we go to the Robit folder, and there's a whole lot of CSV files there, so you can look at them to see what they look like. In fact, I can probably open that just to show you. Right, so there's a very complicated land use file, land use lookup file. See, the first line has got the two headings, land use ID, comma, SWAT code, to say the first line isn't read, so it doesn't matter what's there, but you can't include it as part of your table. All right, you've got to put something there because it will only start reading at the next line. So in this case, the land use number 1 in your map is water, 2 is AGRL, general agriculture, 3 is pasture, and 4 is forest. These are standard plant names. Right, originally, SWAT only had 4-letter codes, except for hay. For some reason, hay was only 3 letters. Right, so that's what a land use lookup file looks like, a CSV file. The problem with them is not creating them, it's finding out what your map means. Because if you don't know what your map means, you're lost anyway. Okay, so we select the land uses.csv and click open. And what it does, it takes the name of your file, which is why it's a good idea to have the name land use, and it makes a table inside your project database. Okay, this means the next time you want to use Robit, the table is already there. And when you want to select a land use lookup file, remember the tool always selects all the files, all the tables in your project database that have the name land use in them. And therefore it will find this one. So you never need to read the CSV file twice. If you do, you'll get Robit land use in 0, and then you get Robit land use in 1, keep reading it. Of course, you might need to do that, but you should change it in the meantime. In general, you only need to read the CSV file once, provided you put land use in its name, so the tool will find it next time. We need a soil lookup table. So again, there's a couple there already, but we're going to import the Robit CSV file. So we're back in the Robit folder, and it's called Robit Soils. Don't pick on Robit user soil, Robit Soils. And I'll show you what that looks like. Right, as you can see, soil names are always incomprehensible. And there's a lot more this time, but you only need the numbers that are actually occurring in your soil map. So again, there's a first line, which is not important. As long as you put something there, it doesn't matter what. And each line has simply got a number and a name which will occur in your soil properties file. All right, so again, the soil lookup table is very similar. Well, essentially looks like a land use table. So you select Robit soils.csv and you click open. And again, it makes a table inside your project database which contains the word soil. So next time you run the tool and look for this, for which soil you want, you'll find Robit soil is already listed. You don't need to learn to load the CSV file again. It's 12 o'clock, just after. Any questions? I need a volunteer who has a problem with MPI.
I think she resolved, and then there was someone like there. MPI, who faced the MPI? You faced the MPI. You resolved it.
So how did you resolve it?
How you resolved it?
Certainly, that's right.
Okay.
Currently, we set for language Korean, but it's, particularly included by Korean or Spain.
Okay. 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 So her working directory name included a Korean symbol, so that's why she was facing that error, and she changed it and she got resolved that error. Okay.
Oh, it was the project path.
Yeah, project path.
Use ASCII symbols. Don't put spaces. Don't put Korean characters into your path
Yeah,
names.
this should be the general rule. Whenever you are naming your folders, try not to use space, try not to use plus sign, because I saw someone who was naming it for a swag plus. Don't use plus sign, okay, in your folder name. Maybe later on you are using Python or R programming to do that stuff, and that plus will create all kind of problem. Yes.
People that resolve the producing results.
Yeah, they do. But you are still facing. So that you may have still using that for.
Right. So you have to remember that Q-Spot Plus was written by this very old Englishman who has no idea what Korean characters are.
So any question up to here before we go for lunch? Yes.
I have another problem.
Yes.
I tried to load the land views.
Yeah.
AD file, but I have it's totally different message. I clicked on arrow.
Okay. Can you stay for 5 minutes and we'll
Yeah.
take a look?
Okay. Okay. Any other error or any question up to here on lookup tables or termination of watershed? Very good. Yes.
The first time we created inlet, the outlet, we removed the one we created.
So the outlet we created.
What's that? You mean when I drew one? No, the only one that will be used by the software
Mhm.
is the one whose name appears on the form.
Right.
Right, so if you've got draw outlets.shape, then it's using the one you drew. And if you've got main outlet.shape, something, then it's using that one. So you can see which one. So it's a good idea to remove the one you're not using,
Okay.
but it's not essential because the form will tell you which one is being used.
Oh, I see.
Okay?
Yes.
Just as we'll see at the moment, we've got three floodplain maps. Yes, we're going to pick one of them to use.
Yes.
And the one that we're going to pick will be on the form. Even though the three of them are still in the context.
So it depends on
QGIS.
we showed you the choosing. Something you're choosing less complex. Don't worry. It's more this space.
So we start together.
It's less complex.
One.
And more.
Is that right?
We will start at 1 bed, and the lunch is in cafeteria, and that I don't know where it is. Maybe, huh?
Downstairs.
Downstairs? Okay. If somebody know cafeteria, you know?
Lobby floor.
Okay, lobby floor. Full lunch.
You all get a lift with that.
Yeah, so there is a lot of wires. Please be careful with the wires or remove it for that. Okay, so it is still 20 minutes to lunch. There is still 20 minutes to lunch.
Hello.
Okay. But you can ask the question or. Yeah. Somebody had more, but.
I want to know.
Only direct from Singapore. So what I was here, that you create in this sample, you take it outside, create it outside, and then come back and use this. Use the distributor with the, or if you want, you can play maybe, and then you can have more. But yes, we control. Yeah, so where we give you all inside difference. You will get, adjust skill, products, yeah, and you will get. Okay, that's it. So, yeah, you will get out, and then you will get results and. So, all multiple knowledge.
I just make define the observation
Yes.
of many point information. And then I can get the all the
Yes, you can draw, so there was an option, draw out. So you can draw those.
yeah.
Then if you throw one after here,
Yeah.
this will be.
Okay.
I think you should do a reinstallation.
There are no options. Yeah, as you make more, you will just more in the place. So these are very more general person.
The soul map and then user map. We can see there's a lot of five.
Yes.
Unnecessary to use the region part, or you can use the region part.
You can use the shape type also.
Yeah.
As long as, because we need those to be in the same projection, medium projection. But you can never use shape type easily in the last projection. But consider the same UTM. And you can.
Okay. So, but we are having a very many of the bad, but that they use the projection.
Yes.
Five.
You can convert it.
Okay.
Yeah, so we have like UTM conversion. It's easy, If so, then we get
It's a problem with that file.
Okay.
It's not reading it properly.